Today, we are going to work on proving triangles congruent. My hope is that by the end of the lesson, you are able to create, you'll be able to tell if two objects are congruent, and you'll have some tools for deciding whether they are or not. So we're going to introduce some new theorems and some all sorts of good stuff. Before we jump too far into this, let's look at some important vocabulary. I know, more vocabulary. It's just, and this is very repetitive, but what I want you to see is that in any given triangle, we have an angle that is opposite a particular side, and we can say that this side is included between two angles. And that's important when we look at some of our congruency theorems. It's a little redundant, so I'm going to let you read and process that on your own. That's not a blank page. So in proving triangles congruent, and you've seen these before, I believe it was in 8th grade when I looked that information up. You've seen these before, but it's still good to review them. I can prove that two triangles are congruent by proving that all three sides are congruent to corresponding parts of a second triangle. I can prove two triangles congruent by saying that two pairs of corresponding sides are congruent, and the angle between them, it has to be the included angle. The angle has to be between the two congruent sides for me to use the side angle side postulate. And when we do formal proofs in the next lesson, we do not have to write side angle side every time you go to define why two triangles are congruent. Instead, we just abbreviate using SAS. The last way to prove, or at least the last way for today, because there are other ways, but the last way for today to prove that two triangles are congruent is to use an angle side angle theorem postulate. My apologies. Angle side angle says that two pairs of corresponding angles are congruent and the included side. Note that the congruent side has to be between the two angles, which is why we went over that vocabulary just moments ago. Okay. So those are the three postulates we're going to use today, and we're just going to look at a bunch of examples. We're going to identify the congruencies, because what you'll notice is in the three postulates we looked at, for each one you have to have three very particular kinds of congruency. So that's what we're going to look for in these examples. If we've decided that the triangles are indeed congruent, we're going to write a congruency statement, which we talked about in ad nauseum in the last lesson. And then we're going to, oh, sorry, I switched these. We're going to provide the postulate that says that they're congruent and then write the congruency statement. So let's just jump in. I'm going to cut to the chase because the first example I prefer to do with you. I'm going to notice that angle AB is congruent to DE, right? And that is a side. The next thing I notice is that angle B is congruent to angle E. I was given that information. That's an angle. And then lastly, I was told that BC is congruent to EF. That is a side. So by the side angle side postulate, I can say that these two triangles are congruent. The only thing I need to make sure I verify is that my congruent angle happens to be between the congruent sides. All right, so that's one good example. Let's look at another one. I can change the orientation of these lovely little triangles to make things a little bit more interesting, and that's what we've done here. So in this particular case, I'm given two triangles that share, you can't see that. Good grief, Charlie Brown. Okay, so in this particular example, in example 2, I'm given two triangles and they share a common side. I notice that the right angles are up against each other. That suggests to me that this is a fold. It's been folded over, it's been flipped, it's a reflection, it's not been spun around in any way, it's just simply folded over. I automatically know that I have some good information here. I was given that angle S to P to R was congruent to angle QPR. And remember, if I'm going to end up in my name with the right angle in the first statement, then I have to do it in the second angle statement as well. I was also given that by the reflexive property, this is what I sometimes call a hidden congruency. By the reflexive property, PR is shared. It is a common side. It's shared in both triangles. And we know by reflexive property that you are equal to yourself. PR is congruent to itself, reflective. And then lastly, I know by the right angle congruency theorem, which we haven't technically covered yet, but we will in the next lesson. Is it the next one? It is soon. We will cover the right angle congruency theorem, and it says that all right angles are congruent. So I was able to say that SRP is congruent to QRP. Based on that, I have an angle, a side, and an angle, and the side is verified as being between my two congruent angles. So this is angle, side, angle, and there is my congruency statement. It's so slippery. All right, so that is another way that we can do, that we can talk about triangles and their congruencies. The next thing that next one we're going to look at, see, I can make these pictures, these similar or the congruent triangles, so interesting. In this case, it might initially to you just look like a parallelogram, but what it's telling me actually is that I've got parallel sides cut by a transversal, and that transversal in this case, as it's drawn, happens to make two different triangles. I went ahead and extended the lines just a little bit in the hope that I'm reminding you that when parallel lines are cut by transversals, that you get all sorts of alternate interior angles, corresponding angle congruencies. There's just lots of congruencies when you have parallel lines cut by a transversal, the most common of which that you will see will be alternate interior angles, and sometimes you'll see corresponding angles. All right, so in this picture, because I have so many different sets of parallel lines, I can say that by alternate interior angles, that MJL is congruent to KLJ. And it's important that you just, make sure you're looking at, and sometimes it helps to actually draw the parallel lines independently. So if I have parallel lines and they are cut by a transversal, then I know that this angle is congruent to this one. And that's those green angles you see right there. Now my picture down here looks considerably different than this picture up here because I didn't do the triangles and I don't have sides and all that. But if you draw your parallel lines off separately, sometimes it's easier to see those angle congruencies. The next thing I know is that JL is congruent to LJ. In this case, folks, this is a rotation. It is not a fold. If I were to actually fold this over, I would find that the vertex M lands up here somewhere. It is not a reflection of the top triangle. So in this case, I am using the symmetric property to identify that JL is congruent to LJ. And then lastly, again, by alternate interior angles, I know that MLJ is congruent to angle KJL. This gives me angle side angle postulate congruency, and I can name my congruent triangles. A lot of times if you have a triangle congruency, an angle congruency somewhere that you have proven, you can use that exact same angle congruency for your triangle congruent statement. I could have used either one of those or this one. There's 3 different ways to name it, and you can choose. So long as your corresponding parts are in the same relative position, you're covered. Here's another example. In this case, I am given 2 triangles. I immediately notice that I have vertical angles. Vertical angles are another one of those hidden congruencies like shared sides. Vertical angles are always congruent. And so that gives me a visual indication that this is just a fold or a flip. I was given that V is congruent to Z. That was given information. I was given that Vx is congruent to Zx. I could tell that by the marks on my picture. And then lastly, by the vertical angle congruency theorem, I know that these 2 angles are congruent. So by angle, the side included between the second angle, angle side angle, I can conclude that WXV is congruent to YXZ. Not very friendly names for triangles, are they? All right, let's just keep rocking and rolling here. Are they congruent? Yes or no? And if so, by what postulate? So in this one, I've got some vertical angles. I was given a congruent side, and I was given another pair of perhaps alternate interior angles. Who knows? But because the side happens to be between congruent angles, I can say that these two triangles are congruent by angle, side, angle. And I don't know where my last angle got lost. I'm going to go ahead and draw that in. Angle, side, angle. For my next one, I'm going to look at this, and I'm again going to say this is angle, side, angle. This picture is very similar to example 3. It's spun around, but it's the same idea. Angle, side, angle. And then this last picture, I want you to look at a little bit more carefully. In this last picture, I was given 2 congruent angles. Those easily could have been gotten by perhaps parallel lines cut by transversals. I also have vertical angles. So you might be tempted to conclude that these 2 triangles are congruent by angle, angle, angle. But you'll notice we don't have an angle, angle theorem. So I cannot say that these 2 triangles are congruent. All right, let's look at a couple more. In example 7, I was given a whole bunch of information and a picture. I like to mark up my picture. If E is the midpoint of segment KW, that tells me that from K to E is going to be congruent to W to E. So I went ahead and marked that. It also tells me that angle KEG, my green angle, is congruent to WEH. And lastly, it tells me angle K is congruent to angle W. Resist the temptation to assume that K and W are right angles. We do not have any information to indicate that, but we do know they're congruent. So I can say that these 2 triangles are congruent by angle, side, angle, because the side that is congruent is between corresponding angle congruences. Here's another one. This picture is really weird. Sometimes it helps, if it does help, feel free to do it. Sometimes it helps to draw the 2 triangles independently. So here's the triangle on the left. Just ignore the segments floating around in the middle of it. Here's the triangle you see on the right. And if I draw those independently, then it's easier to see that angle P is congruent to itself. That would be the reflexive property. It's the same angle in both triangles. And I can see that again when I draw my picture separately. I was given that FP is congruent to HP. I was given that angle F is congruent to angle H. And because angle P is congruent to itself, I can say these triangles are congruent by angle, side, angle. And that's it, folks, for today. That's a lot of information to process, but it's helpful to know. And we're going to use it to write 2 column proofs in the next lesson. See you then.